Good evening. Good evening, welcome. Tonight, I'd like to invite you on a journey of discovery of the many unsuspected, sometimes unexpected ways in which the stars have built our world. From prehistory to artificial intelligence, we shall see that the stars have a lot to answer for in terms of who we are today, and they might even hold the key to our future survival. But first, we need to take a brief personal detour to my own history with the stars and how I came to ponder this kind of questions. It was a very snowy and cold winter in 1999 in Switzerland, where I'm from, and I was then a physics undergraduate student at ETH Zurich, and I eagerly signed up to the astronomy camp. I really wanted to get those measurements of those binary stars done. But as you can see, we were clouded out. No chance of that. And so the professor said, well, you know, we can't see the stars, at least let's try to make some measurements of the sun. Maybe we're going to see the sunspots and measure the rotation of the sun, something like that. And so he instructed us to point our scopes to the sun. And he said, whatever you do, never ever look through the eyepiece directly at the sun, because that's a mistake. You're only going to do it twice in your life, once for each eye. I did as I was instructed. I pointed the scope, took a piece of paper, trying to line up the sun so that the image would shine here and could be safely observed. But no matter how hard I tried, I could not get the largest astronomical object in the sky to fit inside the telescope. And so in frustration and desperation, I did what I was told to absolutely avoid. I bent down and did look through the eyepiece. And I realized a fraction of a second too late, my mistake. And I stood back up, frightened, because I knew that blindness could be almost instantaneous and painless. And then I realized what it was. My ineptitude that saved my life, because you see, the lens cap had been on the whole time. So I realized then that perhaps observational astronomy wasn't my thing, and I went into theoretical physics instead, into cosmology, and I got interested in statistics and now machine learning and trying to understand the stars, but not just the stars, the cosmos, the universe, dark matter, dark energy, the Big Bang, using the big data gathered by telescopes and more able observers than myself. And so it was always clear to me that the stars have a lot to answer for my own life. Of course, my job, my very profession wouldn't exist without the stars. And indeed, my own personal life would be very different without the stars, because in fact, the stars are responsible also for, not responsible, maybe it's not the right word, but certainly have played a big hand in my wife and I getting together and starting a family and all the rest of it, a story that I'm not telling tonight. It's in the book if you're interested. But it wasn't until 2 decades later that I realized something else, something much more profound. I was in the Outer Hebrides on the Isle of Lewis and visiting the Callanish stone circle. That's a megalithic circle going back 5,000 years. As impressive, if perhaps a little bit less famous than its southern England cousin, Stonehenge. I was the lone visitor on that February 2020. Little did I know that the world was about to change, of course, at the time. It was me and the sheep. And this place, of course, stood there for millennia. And the original reasons for building it are lost in prehistory, but we know for sure it had lots to do with spirituality, it had to do with religion, it had to do with astronomy. It's lined up according to the cardinal directions, and particularly it's probably to do with a very special and rare lunar event called the major standstill that only happens every 18.6 years. And as I was standing there trying to make a sense of why all this effort of building this incredible monument, and it was cloudy yet again, I realized that Callanish would not exist if it hadn't been for the stars. And I had this eureka moment. Hang on, I said, is it possible that perhaps everything would be different if it hadn't been for the stars? And I became obsessed with clouds. And of course, at that point, I had a huge advantage because I had lived 15 years in England at that time. And so I knew a thing or two about clouds. And I scoured satellite data looking for the cloudiest place on Earth. And no, since you ask, this is not in England, nor Scotland, actually. I looked for ethnographic evidence of the differences in terms of culture from Australia to the Arctic Circle. I even looked further afield. I looked at exoplanets, and I looked at planets in our own solar system, and it seemed that Venus was a very good place, a good counterpoint. Example, Venus, indeed, completely covered in clouds, our sister planet, closer to the sun than we are, so much so that until the mid-20th century, scientists believed that potentially Venus was habitable, in fact, covered with luscious vegetation and rain, some sort of tropical forest on steroids. Later on, it was discovered that the clouds are sulfuric acid. And the greenhouse effect is such that the surface temperature is about 400 degrees, so not a really pleasant place to be. So then I read tons of science fiction, because I figured maybe the science fiction writers have something interesting to say about life under clouds. Many a novel is set on Venus. I discovered to my dismay that actually most of these writers had a bunch of white male explorers landing on the planet of love, only to find hordes of scantily clad, blue-skinned alienesses. That wasn't really interesting for my purposes, and so I gave up on the notion. And so, because I couldn't find a planet covered in clouds, what I did, I invented my own. Welcome to Caligo. That's exactly like the Earth, except for one consequential difference. Clouds are everywhere all the time. And I asked myself, what would be of us if we had been destined to live on such a planet? And I discovered that everything would be different. And so the stars have, for us, been instrumental not just in timekeeping and calendars, but also in orientation and navigation. They sparkled astronomy, and from astronomy, science and physics. Art and religion were, of course, incredibly inspired by the stars. So was astrology and rituals and a kind of megalithic monuments like Callanish or Stonehenge. But also more unexpected things like sociology, artificial intelligence, not to mention, of course, the star rating system that we use online. And indeed, the five-pointed star itself, that's an Egyptian symbol going back thousands of years. And so I tried to figure out what would have been different on Caligo if we had lived on such a planet. And tonight, I'd like to share some of the highlights with you. Because you see, one of the most consequential facts about the starry sky is, of course, that it is cyclical. Stars circle on repetitive, foreseeable, predictable patterns during the night, but equally star groups, constellations, and asterisms come back regularly during the season, a certain time of the year. Of course, this also changes over time due to the precession of the equinoxes. The phases of the moon have been central in calendars from time immemorial, and also the motion of the planets, more complicated than that of the stars, but yet predictable. In fact, planets comes from the Greek for wanderer, for a reason. Well, that has, of course, puzzled and been puzzled out by our ancestors for a long time. But apart from the predictability of the stars, the starry heaven also gave us reasons to wonder and be in awe, and particularly gave us reasons to place our spiritual beliefs high up in heaven. And all the most powerful gods always lived in the sky, from Zeus from the Greeks to our Lord of Christianity, all of them up in heavens. But the sky wasn't just regularity, you see, the sky was also unpredictable, terrifying events, none more so than solar eclipses that terrified our ancestors because they were entirely unpredictable up until the 17th century. Nobody could predict the solar eclipse. And it's a scary moment if you are lucky enough to witness one. It really scares you out of your wits. I saw one in 2017 in the US, and this black hole of a moon passing in front of the sun. I knew what was happening, and yet I was terrified myself. What if the life-giving light and warmth of the sun never comes back? So those events were really, really powerful omens for our ancestors. And so were comets, these other unruly visitors coming from who knows where, appearing suddenly, unpredictably on the sky. Here is one example among many. What we now know was Halley comet showing up in April 1066, and King Harold of England, seeing the comet, got thinking, this doesn't bode well for my kingdom. At the same time, William the Conqueror in France also saw the star, as they called it, and he said, oh, new star, new kingdom, gang go, I'm going to go over, and well, when the Battle of Hastings happened, you know who won, right? But this is another interesting point about the power of astrology, because you see the astrological impact of events in the heaven is not scientific, it doesn't exist, but actually the psychological effects were very real. People believed in the effect of this kind of heavenly phenomena, and that changed our psychology, and that changed history, in fact. And so, in the many ways that the sky really determines who we are, one of them is timekeeping. Now, timekeeping, of course, has been tied to the motion, the regular motion of the skies that I was telling you about. But when the first clocks show up in 14th century Europe, those clocks, this is an example in Padua, the beautiful astronomical clock on Torre del Capitanato, which is still functioning after so long, one of the oldest of its kind in Europe. Now, those clocks are not merely, not even primarily meant to keep the time. They are actually astronomical clocks. And this example shows the phases of the moon and the position of the sun along the zodiac and the different sort of astrological shapes as well in the sky. And when this appears, it's a marvel. It's apparently born out of nowhere, and the historian Derek de Solla Price has called the clock one of the most consequential technological inventions of humankind. Why? Because this kind of mechanism and the craftsmanship that's required to produce them, well, that comes in very handy when in the 16th century the scientific revolution gets going, and new instruments and new scientific experiments require the ability to produce new kind of experimental apparatus, and clockmakers have got the right skills and right experience. And there is a red line going from clockmaking all the way to the assembly lines of Detroit in the early 20th century and to today's technology. And in fact, this is a marvel of ingenuity, and the clockmakers of 14th century Europe built astronomical clocks as a way of showing man's ingenuity, but also as a way of praising the workings of the Lord. Nothing could be better than copying and being able to copy the wonderful, precise, exact mechanism of the firmament down into a man-made, human-made machine. But even today, when we look at the face of a watch, even today, actually, we are staring back to tradition and stories that stretch back thousands and thousands of years. Because at the beginning, the daily hours were measured using simple instruments such as a sundial. Here is an example from the Valley of the Kings in Egypt, 3,000 years old, the oldest known. And have a look at the subdivisions of this sundial. How many do you count? 12 daily hours, exactly the same number as we use still today. The Egyptians got it from the Babylonians. It's not entirely clear how exactly the Babylonians hit upon 12, but certainly the Egyptians adapted it from the Babylonians and used 36 stars during the night, called the Deccan stars, to measure time during the night, and then they reflected back the same subdivision during the day, something that we use to this date. Here at the center, this hole is where the stick goes, the gnomon, the stick whose shadow tells you the time. And in the northern hemisphere, the sun rises in the east and goes to the west via south. And so in the morning, the shadow looks like this, and say at noon, it looks like that, and the shadow has moved clockwise. Or rather, perhaps, we should say it is the hands of our clocks that move sunwise, because the clocks were invented in the northern hemisphere, and when they were invented, they copied the movement of the sun. And so you see, every time you look at the watch, I think you now be able to connect back all the way to the Babylonians 5,000 years ago. Timekeeping was one way of situating ourselves in time, but the stars have been instrumental in situating ourselves in space as well. And so there are many stories connected to navigation, going all the way back to Homer and Odysseus, and the story of him going back to Ithaca, instructed by Calypso to keep the stars of the Great Dipper or the Great Bear to his left, and therefore ensuring that he would travel eastwards. But among the many stories, I've chosen this one because it's a beautiful story, I think, that mixes science, technology, and culture in a beautiful way. It's the story of the first voyage of discovery of the then Lieutenant James Cook, who in 1769 sails on board the Endeavour on an important scientific mission bankrolled by the king in person. Cook's mission, he being the most able cartographer and navigator of the empire, is what we would call today almost mission impossible. Is to take the Endeavour all the way to the other side of the planet, in the middle of a largely uncharted Pacific Ocean. So that's essentially a surface that is 4 times the surface of the Moon, is to look for Tahiti, which has been visited once before. It's an island about 30 miles in diameter. Get there in good time, set up a top-notch astronomical observatory, measure with incredible exactitude the passage in front of the disk of the sun of the planet Venus, an event that will not repeat itself for another 180 years. So failure is not an option. Why? Oh, because that will enable the king's astronomers to measure the distance of Venus to the sun, and thereby measure the size of the solar system, thereby proving the scientific superiority of England in the scientific world. Amazing. That's the easy part. There's a second part of the mission that I'll tell you about later. So Cook does all of it, and how does he find Tahiti? Well, he's bringing with him the best that science and astronomy can offer him, and at that point, it's a book. This book, a nautical almanac, it's a prototype, has been just finished, just hot from the print by the Royal Astronomer Neville Maskelyne, working out of Greenwich. So Maskelyne has taken up a suggestion which is due to Newton, because you see, at that point in time, how do you tell your location east-west, the problem of the longitude on the planet? Well, the stars are no good, right? Because the stars, they travel all the time, so you cannot use them as east-west reference points. But Maskelyne, following Newton, has pre-computed using human computers the position of the Moon against the fixed stars 2 years in advance. Imagine that. And he has given a copy of this precious almanac to Cook. And so all Cook has to do is to measure the position of the Moon with respect to the fixed stars. The book tells him what this position here, what will it happen Greenwich time. And all Cook has to do is to measure the local time at his position. And so if he's, say, if something that's predicted to happen in Greenwich at midnight happens 9 p.m. local time, that means that Cook is 3 hours west of Greenwich, and so it's 45 degrees away. And so this is a beautiful and actually workable method, although it's quite intense. It takes quite a lot of computation for Cook to work it out, but it does get him to the target. And once he gets to Tahiti, he does his measurements. That's another story. It's a wonderful story, but I want to leave it aside because I want to focus on something unexpected that happens in Tahiti. Once in Tahiti, the British party spends 3-4 months there with their observations, and they befriend a local priest named Tupaia. Now, Tupaia is a high priest, is a political exile for reasons that we don't need to go into, and he's also a master navigator. He has inherited the incredible knowledge of the Polynesian and Micronesian master navigators who, at the time when the Greeks and the Phoenicians, the master navigators of the Western world, were tightly hugging the coast of the Mediterranean Sea, while the Polynesian navigators, they were traveling 4,000 miles between New Zealand and Tahiti and Hawaii with no instruments, no charts, nothing except their incredible knowledge of the sea swells, of winds, of birds, fish, temperature of the water, and of course, of the stars. And so Tupaia, for complicated reasons, decides to leave Tahiti. His life is in danger, he believes, and to embark on the Endeavour. And Cook recognizes his ability as an incredible navigator, and not only does he take him on board, he gives him the task to pilot the Endeavour in the next leg of the journey, because at that point in time, Cook has opened some secret instructions that he carried from the Admiralty, who told him not to dally in the tropical paradise of Tahiti, but rather set sail and go and look for the non-existent southern continent called Terra Australis. We now know it doesn't exist, but at the time, the king wanted Cook to claim it for the empire. So Cook needs a guide, and Tupaia is that guide. Tupaia flawlessly pilots the Endeavour in various islands, always being able to point right back at Tahiti, no matter time of the day or time of night. And the thing is, well, nobody on board the Endeavour ever asked him how he did it. How did he do it? And this knowledge then went tragically lost when Tupaia himself got got killed in Jakarta on his way back. He never made it to England. And of course, imperialism and colonialism meant that the way of living of the master navigators was largely destroyed later on, and that knowledge was largely lost, although it's making a comeback now, and traditional voyaging has been demonstrated in the last few decades. There is one incredible, unique testament of that meeting and perhaps clashing of navigational star-driven cultures. And it is this map here. It's called Tupaya's map. It's been co-created on board the Endeavour by Tupaya and Cook and perhaps Cook's crew. And it shows the position of the islands that Cook wanted to scout out around Tahiti. But there is one catch. The islands that the Brits knew about are positioned in the correct according to the Western tradition way, north, south, east, west. But the islands that Tupaya knew about are placed according to a very different understanding of geography. They're placed with the center of the map here, where the Endeavour is placed, as the reference point. The Voyager is at the center of their own voyage for the Polynesian master navigators, and it is the islands, the sea, the stars that flow all around the still Voyager. A completely different way of understanding navigation and the stars, and one that was completely impossible to understand for the Westerners, and indeed they never even asked, sadly, for us. We move on to science, and I'll be brief because that's a story that has been told many, many times, how astronomy kickstarted the scientific revolution, the Copernican revolution. But I want to highlight a few important points for our purposes. One is that when Galileo Galilei in 1609 hears about this wondrous new machine that has been invented in the Netherlands, he quickly decides to create his own version, and in 3 days he's got a working cannocchiale, as he told him. The word telescope hadn't been invented yet. What does he do? He brings his new invention to the Doge. No, not that Doge, okay? This Doge wasn't in the habit of actually firing randomly brilliant scientists. This one doubles Galileo's salary on the spot, and he gives him a job for life. Because he recognizes the importance of a telescope in war and in military action. But Galileo is not interested in any of that. He goes back to Padua and he improves his telescope, and after a while he gets a much better telescope that has got up to 30 enlargements. And what does he do? He's not interested in looking, at sea, at faraway ships. What he does is something absolutely extraordinary. He takes his telescope and he points it upwards to the sky. He wants to take a good look at God's own abode. And everywhere he points a telescope, new incredible sights come into view. He looks at Jupiter and he discovers the 4 moons of Jupiter revolving around it, proof that not everything in the solar system revolves around us. He points it to the moon and he sees craters, proof that the moon is not a perfect heavenly body like the ancients had believed. He points it to the Milky Way, and all of a sudden he discovers that the Milky Way is made of thousands of little stars, and it's not an atmospheric phenomenon like Aristotle had said, and it's not the place where the souls of the dead go, like Plato believed. And then he points it to Venus, and he discovers the phases of Venus, incontrovertible proof that the Copernican system is right and the sun is at the center of the solar system, a discovery that, of course, will get him in trouble later on with the church. But most importantly of all of these discoveries lead Galileo to formulate this idea that the book of nature is written in mathematical language. And that's a revolutionary thought, because it's the first time that humankind understands that mathematics is the key to decrypt the book of nature, and with it, all of its secrets. Newton comes along, it's a story that we all know, but what is not often emphasized is how universal gravitation, Newton's laws of gravity, have been formulated, motivated, of course, by astronomical problems, by the problem of the movement of the planets in the solar system. And by the time that Newton is done with his Principia, his famous book with the universal laws of gravity, he has even managed to explain the orbits of comets. Comets, those unruly visitors that everybody believed were exceptional and different from everything else, they obey the same laws of gravity as everything else. And by the time Newton is done, he has come up with laws of physics that describe the movement of absolutely everything from an apple falling from his mother's tree in Cambridge to the orbit of the moon to the orbit of comets in the solar system. And that's the start of the scientific revolution proper, and from there all of the sciences follow, and it was started in the sky. This man would deserve a longer time that we have to dedicate to him. Pierre-Simon de Laplace, called during his lifetime the Newton of France. He was an astronomer, mathematician, brilliant genius in many ways. The one bit that I want to tease out about the many things that he did is another important element for our understanding of science. The fact that he said, well, by analyzing the movements of planets and taking one step beyond what even Newton had done, he realized that while observations became more and more precise, it was important to find ways of actually combining them, taking into account measurement error, the fact that observers, as precise as they were bound to make errors. And he realized that by analyzing this data, he said, if we had an intelligence sufficiently vast to submit this data to analysis, coupling this with a theoretical model of the universe, we would be able to predict the future and reconstruct the past. It's the essential idea of the predictability of the world, which is at the heart of every artificial intelligence system even today. And it was formulated for the first time by Laplace by considering the orbits of the planets. The story then takes a twist. There are many different stories connected to this. I chose this one because it's perhaps unexpected. I bet not many of you have heard of this man, Adolphe Quetelet. Anybody has heard of him? No, I wouldn't think so. But you might have heard about, you have, sociology student right there. Perhaps no. But you might have heard about something that he has invented, the body mass index. Maybe, right? His invention. How did that come about? Well, Quetelet was an astronomer, a Belgian astronomer, who studied at the foot of Laplace himself in Paris because he was lined up to become the very first director of Brussels Observatory. But by the time he comes back in 1830 Belgium, revolution has started and the astronomers are no longer needed. And Quetelet is very frustrated because unlike the uncertainty of the stars and the planets that can be exactly quantified, and in particular it can be quantified using a new mathematical tool here, the Gaussian curve, the bell curve that describes the distribution of errors that Carl Friedrich Gauss, the mathematician, has invented and used for the first time to predict the position of the Ceres asteroid in the sky to spectacular success. Well, all of that is good for astronomy, but Quetelet finds that the workings of the human sphere are entirely unpredictable. It's all chaos. Nothing ever follows any predictable pattern. Look at this revolution. It has completely shattered my dreams of becoming an astronomer, says Quetelet. And so, for lack of anything better to do, he starts looking at other kind of data, and he lines up data of the chest measurements of Scottish soldiers. Lo and behold, those data follow exactly the same pattern as the measurement uncertainties in astronomy. It's a revelation. Quetelet starts looking for data everywhere. He looks at limb measurements, he looks at height measurements, he looks at IQ measurements, he looks at the body mass index measurement, he looks at propensity to commit suicide, to get married, to all sorts of things. It all follows the same universal curve. That's incredible. Quetelet cannot believe it because, after all, the same regularity that was first perceived in the stars seems to apply in exactly the same way in the human sphere. It's the birth of sociology, which Quetelet initially calls social mechanics, on the blueprint of celestial mechanics from the sky. Quetelet then goes one step further, one step too much, in fact. He falls in love with this notion of average man, the perfect average, which, for us, average man sounds a little bit even mediocre today, but for Quetelet, average is perfection. And he goes as far as saying everything different from the average man's proportion and condition would constitute deformity and disease. And that's laughable to us, but unfortunately it has very serious consequences because those ideas are taken very seriously, and everything that deviates from the Gaussian curve, which is also called the normal curve, becomes to be regarded as deviant, abnormal, monstrous, has to be suppressed. those ideas then get picked up by the phrenologists and eugenicists of the early 20th century, and they become the pseudo-scientific basis for the fascists and Nazi extermination of everything that was abnormal. And so sadly the stars have much to answer also in that kind of dark page of humankind's history. There are other stories that I need to gloss over. One takes place not far away from here, is the almost invention of computing during Victorian times, and again, born through the stars, through the works of this man, Charles Babbage, who squanders his fortune, his talent, his life, pursuing the unfulfilled dream of a universal computing machine. The only existing prototype is this one that you see in the middle. It's a fascinating story. I don't have time to tell it, but I do want to mention Ada Lovelace, who goes down as the first computer programmer in history. She's the estranged daughter of Lord Byron, a brilliant mathematician, died tragically young, falls in love with Babbage's thinking machines, as she calls them, and writes a computer program in around the 1830s, and that's why she's now goes down as the first computer programmer in history. And it all was born through Babbage's obsession with stellar tables and his obsession with predicting the future using mechanical means. As a very consequential idea, for the first time, the Industrial Revolution, which replaced human muscle power with machines, now tries to essentially go over to the intellectual domain and replacing intellectual capability with machines. Babbage will fail for reasons that we don't have time to go into, but the idea was there and it was born out of the stars again. But I want now instead to go back all the way at the very beginning. There are many more stories from the 20th century to today, but this one to me is perhaps the most fascinating. And my puzzling over the what-ifs of Caligo led me all the way to the very beginning, asking the fundamental question of why are we here as opposed to them, our cousins, the Neanderthals. Because you see, the Neanderthals, by the time we came onto the scene 50,000 years ago, they've been around for 600,000 years. They were well established in Europe and part of Asia. And yet, in the short span of a few thousands of years, they all but disappeared, leaving nothing but fossils at the bottom of caves and about 3% of their DNA inside our own cells, which means that we probably met at some point, biblically met even at some point. Whatever happened, the mystery of their disappearance remains such, but whatever happens, we certainly did not club them to death. Now, the Neanderthals were built like Olympians. They had 30% stronger visual acuity. Their handshake would crush a human's hand. They were much stronger than we are. So whatever it was in muscles. So maybe you think, oh, maybe it was the brains. Maybe we're so, there's a reason why we called ourselves sapiens, right? Yeah, maybe. But I am here to put forward the hypothesis that we had a secret weapon hiding in plain sight above our heads. Now, let's take one example, the cycle of the moon. Like I said, all of the historic early calendars were moon-based because the moon has got a phase cycle that goes around every 29.5 days. If you are a prehistoric hunter-gatherer and you somehow understand the phases of the moon, you understand that every 29.5 days, every 30 days, the full moon rises just as the sun sets, which means you got plenty of light during the whole night to stalk that prey that you haven't quite managed to kill, which means that the nights of the full moon are the best nights for hunting. It also means that if you pay attention to the stars, you might somehow intuit in some way the correlation between certain groups of stars coming up and certain fruits coming to fruition, or certain mushrooms being ripe, or the migration of birds or game, or whatever it might be. So over time, if you pay attention to the stars, you get this little bit extra evolutionary advantage over the Neanderthals. And when the going gets tough, when the ice ages come and go, which happened 45 to 50,000 years ago, these little things, the little extra help that sapiens perhaps got from the sky would have made a whole lot of difference to our capability of surviving. Well, you say, well, that's all very well, it's a great story, but what is the evidence? Well, that's hard. This kind of stuff doesn't really leave much traces in the fossil record, but there are hints, and I want to share with you some of those. One is a series of bas-reliefs carved into the rock, which are called Venus statuine. And they depict typically female bodies, always with very prominent sexual traits. Here you see the Venus of Lossel, which goes back about 25,000 years ago in a cave in the Dordogne region of France. It's a hymn to feminine fertility, we think, or anthropologists think. But look at what she's holding in her hand. What looks like a bison's horn, perhaps even a crescent moon with notches, and there are 13 notches in here. 13 is a significant number. It's the maximum number of full moons in a year, which is an important number if you want to be able to sync up the lunar calendar with the solar calendar. It's also the number of days between the new moon and when the moon appears to be full. It's also a number of days between menstruation and ovulation. And so perhaps the moon cycle is linked up with the fertility cycle, and indeed the coincidence of the 30 days moon cycle and womanly cycles, well, it remains unexplained, but certainly would not have escaped early prehistoric women. And perhaps that's a hint that indeed people were paying attention way back then. Another piece of evidence is in the form of this baboon bone going back 43,000 years. And it contains, it has a series of notches along its length, 29 of them. To be fair, the bone is broken off at one end, so we don't know whether the series actually ended at 29. But again, this is a tally of some kind. It's also been heavily used. It's highly polished, as if somebody had used it over and over and over again. Could those be examples of early lunar calendars? Calendars that would keep track of something really, really important to those prehistoric people. Something like the cycle of the moon, or perhaps the menstrual cycle for women, or perhaps the two together. And if this is correct, then this would make women not just the first astronomer, it will make of them the first mathematicians as well, which is something I like to think to be true. There are other tantalizing pieces of evidence. One comes from ethnographic contemporary evidence, the usage of message sticks by native people from Australia. Because one of the hypotheses is that maybe we weren't cleverer than the Neanderthals, but we were better networkers. We could meet up much more frequently than they ever could, and we could therefore exchange tips, ideas, knowledge, technology, different bands of sapiens getting together and like in a tech fair, and exchanging ideas and making sure that every technological innovation would travel further and spread to the whole population and not die out with its inventor. And something like this happens, or used to happen in historical time in Australia, where Aboriginal people sent message sticks, you see here, a piece of bark with inscriptions on one side, showing where the sender is at the intersection of these rivers, when the message was sent. Here, this symbol there, showing the new moon. On the other hand, that's an RSVP invite. On the other hand, that's where they're going to meet, at the intersection of these two rivers, and that's when they're going to meet, at the full moon. And so, could prehistoric sapiens have used something like that to meet up and have all of these all-important exchanges? We don't know. But one thing we know is that the native Australia, the Aboriginal Australians, they used the stars in what they called the dream tracks. They used song lines that connected the stars as aide-memoire in order to memorize the route that they would take in very long overland journeys that they would do across the outback of Australia. And so they learned the route by memorizing the position of the stars and hanging to each star a wayfinding position, a tree, a rock, a river, whatever. And then during the day, when the stars were not visible, they would sing the same songs and remember the route thanks to the stars. When the Western settlers arrived, they followed the first people around. They placed villages along the routes, and those villages grew into cities, and those cities grew a highway system. And the highway system of Australia today, this reflects, even to this day, the song lines that were a reflection of the sky and the stars above. So there we go, unexpected ways in which the stars are all around us today. I got one final piece of evidence for this conjecture that the stars made the whole difference to sky-savvy sapiens. The Pleiades. The Pleiades, a group of stunning blue stars which can be found near the constellation of Taurus, the bull. Here they are. They are so stunning, they're not very bright, but they are unmistakable in the sky, and they've been recognized by all civilizations in all historical times in different ways. We call them the Seven Sisters, but other civilizations call them something else. For example, the Japanese, for a long time, they called them Mutsuraboshi, meaning 6 stars, and indeed the Subaru car maker has got the Pleiades as its logo. Subaru means getting together, and the Subaru company was formed from the merging of 6 companies. 6 companies, not 7. And in fact, despite the fact that we call them the Seven Sisters and have done so for a very long time, in the 3rd century BC, the Greek poet Aratus already wrote, 7 are they in the Song of Man, albeit only 6 are visible to the eye. Yet not a star, I ween, has perished from the sky unmarked since the earliest memory of man. So that's a mystery right here. Why do we call them the Seven Sisters if there's always ever been 6 visible with the naked eye? And indeed, if you believe that this beautiful painting in the Salle de Taureau in Lascaux in France depicts, like some have put forward, depicts the same constellation of Taurus and the same Pleiades in the sky, if this shows that 70,000 years ago, people saw 6 stars in the sky, exactly like Aratus said. The mystery deepens because you see, it turns out that this idea of the 7 sisters, the Greek myth of the 7 daughters of Atlas and Pleione that Zeus put in the sky to shield them from the unwanted advances of Orion, well, exactly the same myth is found in countless variations among Australian Aboriginal people. People who had no contact with ancient Greek before the arrival of Western powers in the 17th century. So how comes then that they both talk about 7 sisters in the sky? Is it possible that there were indeed 7 sisters once upon a time, and those myths are long lost reflections of that knowledge that we might have had since the very beginning? Astronomy perhaps has the answer, because you see, this is a close-up view of the 7 sisters, part of a much bigger cluster counting hundreds of stars, while the two down here, Pleione and Atlas, are now too close together to be visible as 2 stars with the naked eye. But 100,000 years ago, they would be far apart enough for a human of average eyesight to see them clearly. So there were 7 sisters in the sky when we left Africa 50,000 years ago. And could these legends actually be the memory of that interest that we took in the sky? We don't know, but I like to think it's so. Now, all of this is all very well, you might ask and say, but what is it to us today when the glow of our heavily light-polluted cities obliterates the sky? We no longer experience that lived connection with the stars. In fact, we all live in cities, we hardly see anything from the big cities, and sky pollution is getting worse and worse every year. Long gone are the days where you could see the Milky Way even from central London before the invention of electric light. Can you believe it? And of course, you know, we care less about what we don't experience. And the paradox of our age, you see, is that we are instantly transported to the furthest reaches of the universe through our smartphones and our devices that connect us to the amazing pictures that we get from space and ground-based telescopes. Yet we hardly ever look up anymore. And when we do, there is very little for us to see. Our connection to the stars that has done so much for us is almost entirely lost. But there is another, even more pernicious threat going on above our heads that I want to talk about tonight. Apart from light pollution, you could still escape. Difficult in Europe, but if you go to Scotland and the Hebrides, the Outer Hebrides, you find some pretty dark skies still. And you could still hope to experience some of that sense of awe and connection with the stars if you seek out those dark skies. But like I said, there is another problem, another menace, and that menace is satellites. in the last few years, a new space race, a commercial space race has meant a vertiginous increase in the number of low Earth orbit satellites, particularly by this one company, Elon Musk's Starlink system from SpaceX. So this has been a really fast growth of those satellites whose purpose is to offer internet access to everywhere at all the times. And because there are so many, they are rapidly filling up the sky. There are 5,000 satellites that we put in orbit from the Sputnik in 1957 to 2018, and Starlink has put another 7,000 or so in orbit recently in the last 5 years. And if everything goes according to their plan, there's going to be 100,000 satellites in the sky by 2030. What that means is disaster in many ways. For one thing, there is no police, no highways, no rules up there. If two of these satellites zipping around at 28,000 kilometers an hour would collide, well, that means a great deal of fragments, space trash, that would then hit other satellites and fill orbit with debris, and making, therefore, access to space almost impossible for the future. But there is another problem. Those satellites, they are cheap, and they're designed to come back and burn up in the atmosphere every 4 or 5 years. So the mega constellations, they need constant replenishing with launch upon launch upon launch, quite apart from the fuel being spent there. The big problem is that all of the heavy metals that these satellites contain are burning up in the ionosphere, the upper part of the atmosphere, changing already now the chemical composition of a crucial shield that protects us from cosmic ray, with unknown and little-studied consequences. So you see, space is becoming an urgent environmental issue, just like the rainforest, just like plastic in the oceans. We are now encroaching upon space, and we're rapidly doing so without oversight and without recourse. Those satellites also, because they're so low, they also reflect back the light of the sun. And therefore, this is what our skies look like today already. This is a 30 minutes exposure. Each one of those dashed lines is a satellite. And, well, good luck in trying to recapture what Emerson said is the perpetual presence of the sublime in this kind of situation. And so the space barons that are polluting the sky in this way, well, they got a solution. Let's say, let's go to space. Take a joyride on board one of their rockets, of course. If you've got, a few millions burning your pocket, you can do that today. But what is more, they say, we should leave the Earth behind. We should become a multi-planetary species, head for the stars. And that's going to be our solution. Because, say that things become really difficult on this planet. Say that we end up wiping out ourselves through nuclear war or climate change or super intelligent AI, all technologies that they are peddling, of course. Well, let's leave and go and live through the stars. Let's colonize Mars. That's the stated aim of Elon Musk's SpaceX. Well, I wouldn't want to be on Mars. Because the thing is, this is a red herring. It's a weapon of mass distraction. They are pulling, a wool on our head, our eyes, by making us believe that we would ever be able to colonize this place in time to save us from ourselves. This is not going to happen. We don't have the technology, but even if we did have the technology, and we might reach Mars within our lifetimes, it's one thing to go there and back, it's another thing to colonize this place. Look at the difference. This is not the place to live. There is no B planet. Our stand is made here on this blue planet. And so I believe the stars do have an answer still for us. But it's a very different answer than what the space barons say. And the answer lies, perhaps, in what is called the overview effect. It's the feeling that grips many an Apollo astronaut when they look at our blue marble, a beautiful blue dot from a distance. They look at it here from the orbit of the moon. Those are Apollo space mission astronauts, men that were chosen because they were absolutely rational, cold-blooded, and very balanced, psychologically balanced. Yet many of them had a kind of spiritual awakening when realizing the fundamental unity of our planet, the fundamental fragility of our cosmic home when seen against the vicious black of space. Because the truth is, we are not going to leave this planet anytime soon, and many astronauts have realized the need to look after our planet better than we are doing now. They realize that there is a fundamental requirement of sticking together because there is no political borders when you look at Earth from space. Now, this view of our planet, of course, is not available to many of us, but we can take advantage of something that Samantha Harvey has called the reverse overview effect, the sense of awe that grips us if we look up in a dark night, while there still are dark nights and the satellites are not everywhere, and we get lost into the beauty of the cosmos all around us. We feel small, perhaps insignificant, and perhaps we feel the uniqueness of life on our planet. And that reverse overview effect is urgent for us to recapture if we are to understand that this is our only cosmic home. I want to leave you tonight with a message, and that message is one of the messages that's on the Golden Record. In 1977, when the Voyager probes left to go and study the outer planets of the solar system, planetary scientist and science communicator Carl Sagan came up with a brilliant idea. He realized that the probes would one day get lost into interstellar space and would intercept another star 40,000 years from now. And so he added this golden record to the mission. On the cover, you see here, etched in gold, you see instructions for how to play the disk, and also a map of sorts showing the location of the sender with respect to the pulsars nearby our solar system. Inside the records, greetings, messages, technology, pictures, sound from our planet, which perhaps one day somebody will pick up. And I want to leave you with one of the many messages on the Golden Record, one that I think it's urgent for us to hear today. And with that, also one of the pieces of music that's on the Golden Record, this quartet by Ludwig van Beethoven. Among the sounds, pictures, and greetings on the Golden Record is a message from the then US President Jimmy Carter. Written in 1977, Carter's words ring with even greater urgency today. Of the 200 billion stars in the Milky Way galaxy, some, perhaps many, may have inhabited planets and spacefaring civilizations. If one such civilization intercepts Voyager and can understand these recorded contents, here is our message. This is a present from a distant world, a token of our sounds, our signs, our images, our music, our thoughts, and our feelings. We are attempting to survive our time, so we may live into yours. We hope someday, having solved the problems we face, to join a community of galactic civilizations. This record represents our hope and our determination and our goodwill in a vast and awesome universe. Should anybody come looking for Earth in a distant future, guided by the 14 pulsars on the Golden Record's cover, will they be disappointed to find a dead planet, a cosmic tombstone marking the hubris of the naked ape? Or will they marvel from the orbit of Jupiter at our beautiful blue dot, sparkling against the dark? Whether or not we believe that we will one day join a community of galactic civilizations, it is our urgent task today to halt the march of the mega machine, to repurpose its planetary power so it may serve the needs of all life on Earth, to fortify ourselves, not merely to survive our time, but to create a new age. There is something profound in the gesture of launching a disk the size of a dinner plate into the void between the stars, hoping against hope and reason that sometime, somewhere, somebody or something will pick it up. Remember us. We existed, says the disk. We are starborn, and to the stars we entrust our memory. Thank you.